Hi, and welcome back to the next video in our Objective-C tutorial series. My name is Johan and I will be your host in this video. So in this video, we are going to explore memory management and automatic reference counting in Objective-C. So memory management is a critical aspect of programming, especially in languages like Objective-C and C that don't have automatic garbage collection. Proper memory management ensures that your application uses memory efficiently and avoids memory leaks. In Objective-C, memory management revolves around the concepts of retaining and releasing objects. When you create or retain an object, its reference count increases. When you release an object, its reference count decreases. When the reference count reaches 0, the object is deallocated and will be kicked out of memory. So before Arc was introduced, developers had to manage memory manually using retain, release, and auto release. Let's see how this worked. So let's go to our auto release pool. Let's actually delete what's inside there so that we have some space to play with. Okay, so here's an example of manual reference counting on Objective-C. Let's actually create an NS string. So we're going to say NS string. And this is going to be str is equal to, and then we're going to say NS string alloc. And then outside, we're actually going to say init with, I think it was with string. Yes, exactly. Then we're going to say add string. And we're going to say hello Objective-C. Just like this. Let's close this off. And after that, we're going to do, of course, but it's actually complaining that init with string is a literal is redundant. We actually don't need to do that. But for now, I just want to show you guys how this works. So now we can do nslog. And we're going to say add string. Percentage add. And then after that, we're going to do str. Okay. And now we can actually open this one up. And we can actually say str. We can actually say release. And this is releasing the object. So let's run this. Let me see. Oh, yeah. So we actually can't release inside when we're actually using automatic reference counting. Arc forbids this. But this is actually what I wanted to show you. So this is how initially you would actually create a string. So you actually do ns string of string, str. This is ns string and we allocate some memory. Then we do init with string hello Objective-C. After that we print it. And after it is printed, we use release. And using release, we actually kick it out of memory. But because Objective-C has actually been updated over the years, we actually don't need to do this anymore. Because we actually have something that is called automatic reference counting. And as you can see, Arc doesn't allow the use of release anymore. So we can actually get rid of this now, because this was only to show you guys how it was done initially. Now we can actually talk about automatic reference counting. So automatic reference counting was introduced to simplify memory management in Objective-C. With Arc, the compiler automatically inserts, retain and release calls for you, reducing the risks of memory leakage, and it also simplifies coding. So under Arc, you no longer need to manually retain and release objects. The compiler takes care of it based on the lifetime of its object. This makes your code cleaner and yes, less error prone. So let's use some Arc. So inside here, we can actually say, let me see, we can actually say ns string, just like this. Then we're going to say str is equal to, and then we're going to say ns string, and now alloc, just like this. Yes, exactly. And after that, we actually do the init with string, what we did before, right? And we actually don't need to manually release it anymore. So when we do this init with string, that's this one, and we're gonna do, let me see, add, and this is gonna be hello arc or arc, just like this. And now we're gonna do nslog add. I'm gonna do this, and then we're gonna call str. Okay, so when we run this, let's run this. So it prints hello arc, and after the moment when it's actually printed, it actually gets kicked out of memory automatically, and this is what arc does. So the moment we initialize, so the moment we start up the program, this is stored into memory. Then we actually display hello arc on memory. That's here. And the moment when here it is not announced anymore, so str is not used anymore, it's actually being kicked out of memory. So this is actually what arc does. So now you actually don't need to manually release the object anymore, because other release pool, so arc, actually does this itself. So Objective-C provides property attributes that help manage memory automatically. The most commonly used attributes are strong, weak, copy, and assign. So maybe if you actually used UIKit in the past with Swift, you maybe actually remember strong and weak references. And it actually means if it's a strong reference, it actually increases the reference count, and it actually makes sure that the object stays into memory. The moment when you use weak, so a weak reference to the object actually doesn't increase the reference count, and the reference count is going to be set to nil, and the object is going to be deallocated. So this actually means that the object is going to be kicked out of memory. So arc actually frees up memory if you don't use a strong key, a strong reference. You also have copy, and this actually creates a copy of the object. And we also have assign, and this is used for primitive data types, and this doesn't affect reference counting. So let's use some property attributes, right? So let's actually go to the person.h. And as you can see, here we have add property, right? And we actually use non-atomic, and we use strong. So with strong, we actually create a reference count of the name, of the person's name. That's actually what we do. After that, we also have assign. So this actually doesn't do anything, but now we can actually say add property. And we're going to open this one up with non-atomic. Non-atomic. And we can actually say copy ns string. And this is going to be nickname. And last but not least, we're going to take assign. We already used assign. We can also add property non-atomic. We can actually call weak. And we're actually going to take ID. And we're going to say delegate. Just like this. So just to explain this to you guys one more time, when it's strong, it actually increases the reference count. So it actually makes sure that it stays in memory. Assign doesn't really inflict anything at all on arc. Then we have copy. Copy actually copies the property. So in this case, the nickname. And non-atomic weak. So the weak keyword or property or attribute actually makes sure that delegate, that the reference count is actually decreased, and it will actually get kicked out of memory when we don't need it. So now we can actually look at the retain cycles. So retain cycles occur when two objects hold strong references to each other, preventing either from being deallocated or kicked out of memory. This can lead to a memory leak. So using weak references helps to avoid retain cycles. So let's create an example on how to avoid it and how we can use weak references. So we can actually create a new header file. This is going to be a car. And we're going to create a new, we're actually going to make a new file. It's going to be an Objective-C file. And we're going to call this car. And then inside the car.h, we're actually going to import foundation dash Oh my god. Foundation.h. Perfect. And now we can actually, let me see really quick. Yeah, exactly. So then after that, we're actually going to do import. And we're going to say the person.h. And now we can actually say add interface car. This is going to be of ns object. And we're going to say add property non-atomic strong ns string. And this is going to be the model. Now add property non-atomic. And we're going to say strong. This is going to be person. And we're actually going to say owner. Just like this. Now we actually go to the persons file. That's the person.m. Actually, let's first go to the person.h. And in here, we can actually add property non-atomic. And this is going to be a strong reference. We're actually going to say car. And this is going to be car. Now we go to the persons.m, to person.m file. And inside there, we're actually going to do import. And this is going to be car.h. Perfect. So we actually imported the car.h. And now we go back to car.h. And we also have the person.owner. Now we go to the car.m. And in here, we're actually going to do import car.h, just like this. And we're going to say add implementation. This is going to be car. Perfect. 3, 2, 1. One more thing, we actually have to go back to the person h. And above the, oh yeah, of course, it doesn't exist yet. So first, under here, we can actually do add class car, just like this. And this way we can actually call the car here as well by actually adding the class. Okay, so we have two classes. We have the person and we have the car, each with a strong reference to another. This creates a retain cycle because person holds a strong reference to car and car holds a strong reference to person. And you can actually fix this by actually going to the car.h. And in here we have person strong. We actually can make this a weak. And this actually makes sure that we don't have a retain cycle. So the moment when this value is not needed anymore, it's actually going to be kicked out of memory. If you don't do this, you actually get a retain cycle, and you're actually going to use a lot of more memory. So what actually is a memory leak, right? So when you actually are trying to work with properties and you actually try to make references to each other, make sure always one of the two is a weak reference instead of a strong reference. Even pauze. 3, 2, 1. Okay, so now we actually have put everything together. And we can actually make a practical example of managing memory with Arc in a simple application. So let me see. We did that. So let's actually go to the main.m. And inside here, we can actually get rid of it, so we don't need it. Now we can actually say person is equal to, and we're going to say person alloc init, just like this. And now we're going to say person.name is equal to JSON person.h is equal to, what are we going to say? Let's say 28. Oh, we actually forgot the add here for the string. Perfect. And now we can actually say ns log add And we're gonna say name. This is gonna be the let me see really quick. Person dot name, and then we're gonna do add nslog like this. And now we're gonna say age, and this is gonna be LD. Sorry, we need to make this a string. Age LD, comma person dot age. Oh, we made a mistake here. This has to be 28, not a string. Just like this. Perfect. And now the person.age, we're actually going to add long in front of it. Okay, so we create a person object and we set its properties. We print the name and age properties using nslog, and Arc automatically manages the memory for us, ensuring that the person object is deallocated when it's no longer needed. So running this program, as before, will actually run the code and will actually print what we need to do. And after that, it actually will kick this out of memory. So don't forget, Arc automatically kicks stuff out of memory or deallocates it when we don't need it anymore. After that, when we go back to the car and the person, so the person has, here it is. So the person has actually a strong reference to car. So when we go back to the car age, make sure that this reference is weak. If this also is strong, you're actually gonna get memory leaks, okay? Because strong stays in memory, weak leaves memory, okay? So in this video, we covered the memory management of automatic reference counting. We could do this manually, but because Objective-C has been updated over the years, we don't need to do that anymore because the other release pool actually does it all for us. We learned about the attributes, so the strong reference and the weak reference. And always make sure that when you make a reference to another class or to each other, that one of the two is weak. And don't forget that, that's actually really important. Because otherwise you get retain cycles, and with retain cycles you get memory leakage. And of course, these days, when you have like modern iPhones, they have like 8 gigs of memory. It doesn't really matter anymore. But on the other hand, if you work for a client and you are not managing your memory correctly, they actually don't like that, because I think it's actually also good for you guys if you actually learn how to build memory efficient code, right? So that's why this is important, especially in Objective-C. So thank you for watching. In the next video, we're going to dive into collections, so arrays, dictionaries, and sets. And that's also going to be really interesting. So once again, thank you for watching, and I see you next time.